Alright guys, as promised, here are the notes for 8.6. My lesson objectives are to discover the formulas and methods for calculating the area of annuluses, sectors, and segments of circles. So let's first define what these three things are, and then we will get our formulas for finding area. So the first thing is a sector. The sector is the region between two radii of a circle and the included arc. So if you look at that picture, that yellow piece, that is the sector. Kind of think of it as like the slice of pizza. So we're finding the area of just that slice of pizza and not the rest of the pizza. Segment of a circle is the region between a chord of a circle and the included arc. So again, if we look at this diagram, it's that green shaded region, and that would be like the crust of a pizza rather than the whole slice. So you'd be finding that sector, except you're taking out that triangular portion. And then the last thing is an annulus. So the annulus is the region between two concentric circles. Sticking with the food theme, it would be like the donut that's left over when I pluck out the donut hole or I take out that munchkin. So that would be the annulus, just that outer ring. So how the heck do I find the area of a sector? Well, the area of the sector is finding a part of the area of the circle. So if you look over here, I'm reminding you that A, that central angle, and the arc are going to have the same measure. Now if I want to find the area of the sector, what I'm going to do is take the fraction of the circle that that sector represents and multiply by the area. So if you look here at this little diagram, A represents the arc measure, which would be the same as the central angle measure. So A over 360 gives me the fraction of the circle, times the entire circle will give me the area of the sector. We all know, hopefully by now, that area of a circle is pi r squared. So you're going to have to be given at least two pieces of information. So you're either going to be given the angle or arc measure and the radius and asked to find the sector, or maybe you're going to be given the area of the sector and asked to find either the angle measure or the radius, depending on the situation. So I'll show you one example, and then we'll do some more tomorrow in class. So the area of the sector, get rid of this jazz here, the area of the sector would be found by using the A, which is the central angle or the arc measure, and the radius as given. So it is the fraction of the circle, 50 over 360, and then times the area of the circle. Well, if my radius is 5, then it would be 5 squared pi. Now, the directions ask me to leave my answer in terms of pi, so I don't want to press the pi button on my calculator. But when I put 50 divided by 360 times 5 squared, I am going to get a decimal. So that would be 3.47 pi and then centimeters squared. So the 3.47 is 50 divided by 360 times 5 squared, but the pi should be left there. And we will practice some more of these tomorrow in classes. So next we're going to talk about finding the area of the segment of the circle. So remember, the segment of the circle is just the crust of the pizza, so not the entire slice. So what I can do is I can add my triangle in here because there isn't one given to me necessarily. And now I can look at how I can use that to find my area. So what you would want to do is find the area of the sector, which we just did. So angle over 360 times pi r squared. But then you're going to subtract from it the area of a triangle, which you know is 1/2 base times height. Hopefully you know that. So if you look down here, here's an example. So A is the arc measure. So A over 360 times pi r squared, you're going to have to be given the r. And then 1/2, and then base times height. So if you look at this triangle, this is my base, and that's my height. If that were a right triangle, so let's scroll back up here for a second. if I said that this here was a right triangle, then my base and my height would be the radii. Okay, so that sometimes may be true, sometimes may not be, but that is something to sort of watch out for that could be thrown at you. So how would I find the area of this shaded segment? Well, I know the radius, so I know the radius is 6. I know the central angle measure is 90. So first I want to find the area of the sector. So 90 over 360 times, and then it's going to be pi r squared. So my r is 6, so 6 squared, and then pi, minus the area of the triangle. Well, this is an example like I just said. So we've got a right triangle. Base and height are going to be perpendicular. 6, this guy would have to be 6 as well because all the radii have to be the same. So 1/2, and then my base is 6, and my height is 6. So this would be 1/4 of 36 pi. Don't laugh at my writing, this isn't as easy as it looks. Minus, and then half of 36 is 18. So 1/4 of 36, so I have 9 pi minus 18 centimeters squared, and that would be my area. This is the exact answer. I could certainly throw that in my calculator if I wanted to find the approximate, but that's not really necessary. So, and that is finding the area of a segment. Last but not least is finding the area of the annulus. Hopefully this one kind of comes out at you. I'm going to call this one little r because it's the radius of the little circle, and then I'm going to call this radius big R because that's the radius of the big circle. So to find the area of the annulus, it's going to be big R squared times pi minus little r squared times pi. So the area of the big circle minus the area of the little circle is the area of the annulus. Okay, so here's one example of finding the area of the annulus. So if you look, the inner circle has a radius of 6. Now this segment is 3, but if you think about it, the radius of the entire circle is actually going to be 9. So the radius of the, the radius of the entire circle is going to be 9. So the radius of the big circle, or big R, would be 9. The radius of the little circle, or little r, would be 6. So to find that area, we would do 9 squared pi minus 6 squared pi. So my area would be 45 pi, and then whatever my units is would be added to the end. And that is it. So when we come in tomorrow, we will do some examples of each of these, and then we'll move on to 8-7.